Okay, I've set up the same motherboard here, the top board, and then this is the middle board. And I've got the fiber optic cables connected. And then I have the 12 volt supply here. Alright, now that forgot to mention the previous small board, the bottom board, that had a 24 volt supply, which I didn't mention at the time. So you would have to provide 24 volts to that to do the similar test. But here we have 12 volts. Alright? Now when you're when you're checking the operation of the two boards, okay? Now here I have the switch. Can you see this? I hope you can. I use this switch. In this case, we don't care about the power control. We're concerned about the signals getting to the middle board, and that the middle board is working properly. So I will. Let's see if I can zoom in a little bit. I will turn on the switch. Then you see this light turns on over here, right there. And you notice we got not only the four green lights, and the green lights indicate that each of the four sections have their power supply working properly. And the orange light indicates that you have a signal that's come through the fiber optic cable that arrives at this particular circuit, and that circuit is working properly. Now watch, if I disconnect number one, the light goes off. So let me connect that back. I'll zoom in at this point on that board, because that's what we want to concentrate on. Alright, so the way the circuit works is the signal, as I described, comes through the fiber optic cable. It goes to the fiber optic receiver. Okay? And then the fiber optic receiver sends a signal out to this chip, and it goes to pin number 2. Unfortunately, we can't see that, and I have to move this. There we go. Let me tip this up. That'll be a lot better, I think. Maybe too much. There we go. A little more. There. Okay, so the signal comes in through the fiber optic, it goes to the receiver, and then it outputs to the pin number 2 of the chip. And you can see it right there. Then the chip outputs through pins 5 and 6. I'll turn this back down again. And then you have a NPN transistor here and a PNP transistor there. And the signal goes to the base of those transistors. It goes through these resistors here. You have 2 little resistors. Let me zoom in a little bit more. No, that's good enough. The signal goes through the resistors. They're 1 ohm each, and ends up at the gate of the MOSFET. The MOSFET, of course, is on the bottom of this board. So that's how that circuit is working here. In the event that you don't have an orange LED, if there is a failure of the MOSFET, well, what you'll find is first the orange LED won't turn on, and oftentimes either of the two transistors might be bad. One indication that your transistors are bad is if you find that the resistors, the 1 ohm resistors, that they are also bad. They would go bad if you had an overcurrent situation, and if it's an overcurrent, then the transistor is probably going to go bad too. Usually the chip, the little chip here, that doesn't usually go bad, nor does the fiber optic receiver. So there we are again. That's the gate waveform to the MOSFET. In this case, it's gate number 1. Sometimes if you have a failure of the gate, it may also cause a problem with the power supply, which is on the bottom of the board. And that power supply, it has an input of 12 volts and an output of 12 volts. So that would also have to be checked. Something else, just make sure your screws are always tight, especially your gate screw. You have 2 diodes over here. If they were shorted out for some reason, you would have to remove them. I think that's pretty much everything. I don't know what else to say. We'll go back to the main board. A few other things I can talk about. Now it's possible, if you're not heating properly, you may have a problem. There's a cable that connects to, this is considered J7. There's a cable that connects to this. This is a cable that measures the current. And under normal circumstances, the voltage comes in. The voltage comes in through this connector, and it goes to these 2 small chips. But after that, I can explain it, but it's kind of complicated. Basically, you're coming in with a sine wave. It gets changed to a square wave. And then, if you're really attentive, between the 2 small chips here, you have a point where you can measure, but since I'm not running, I can't measure anything, but between the 2 small chips, there's a point where you can measure, and you should see it's called a sawtooth, which is like a triangle. It goes positive and negative, positive and negative. And that triangle should be working. And it should be equal. Like it would be positive 2 and minus 2. Positive 2, minus 2. And then the output from that circuit is pin number 1 of the second chip, right there. The output of that. Okay? It's not running now, but I can just point to it. That would be your output, and then the output goes over here to the phase lock chip right there. And you should see a square wave there. And then on this phase lock chip, and you go to pin number 2, and you should see another square wave, and it should be equal. Pretty much, if you got all that, the machine should work properly. But I can't really explain in great detail unless you have a scope, and unless I'm actually running the machine. So I've tried to describe the fundamentals. Now, of course, the question here, you have these two potentiometers. They're used for adjusting the frequency lock, but they come pre-adjusted. And I don't remember ever having to readjust them. But to readjust them, you would need a current sensor and an oscilloscope, which of course I have. So we'll just have to assume that these are pre-adjusted and they don't need any more adjustment. One other thing I guess I can talk about. When you're running, you have a blue LED right here. Blue LED. That should be on. That indicates you're actually heating. Some of the older systems, when you're running properly and you have frequency lock, you'll have a blue LED up here that will turn on. That's a good that's an indication you're in frequency lock. Now, on the new system, you'll have a blue light over here indicating frequency lock. I use a switch on the new board. I have a switch that simulates that the frequency lock is working correctly. And also, on the new board, you have a green and a red LED. That also measures frequency lock. If you're wait a minute. Okay. You'll notice when you're not running, you'll have a red LED because obviously you're not in frequency lock at that time. Up here. I want to make sure you can see that. I have to zoom in. When you're not in frequency lock, you'll have a red LED, and we have. But I can simulate the machine running by flipping this switch. And now we have a green LED, and over here, we produce the blue LED indicating frequency lock is okay. So that's pretty much everything. That's as much as those are the basics. Those are the basics of the system. I don't know what else to tell you. If you can identify a problem based on this video, then that would be good. So I'm going to stop the video. We're already at 13 minutes. So that's pretty much all I can tell you at the moment. Some things you can test with a voltmeter, but having an oscilloscope like this really helps. Why? Because it's a high frequency system. You need to look at the waveforms. So I'm going to conclude this video right now. Thank you for watching.